Assalamualaikum and greetings to all the panel members. Today I want to present about the characterization of zinc-strontium-lithium phosphate glass doped with copper oxide. So this is our team name, which is PZ Electronics, and the introduction of the project is about to prepare the glass using the selective composition to analyze the electrical, thermal and structural properties of the glass system. So my name is Nur Shahida binti Abdurrahman and my fellow team members is Siti Nabila binti Zainun. We are from Bachelor of Science, University Technology Malaysia, and we are under supervisor Dr. Nur Hafiza binti Hasim. So we proceed with the problem statement. It is limited and not well investigated through the four characterization include the differential thermal analysis, electrical impedance spectroscopy, X-ray diffraction and Fourier transform infrared with increasing the copper oxide concentration. For the literature review, we can see the objective is to prepare the new glass system by matte quenching method and to determine the amorphous nature, physical, thermal, structural, and electrical properties of the glass system. So the approach and concept, we use the raw materials, which is phosphorus pentoxide as a host, zinc oxide, lithium oxide, and strontium oxide as a modifier, and copper oxide as a dopant. Next is the strength of existing innovative solution and their weaknesses. So phosphate glass as a degradable biomaterials and antibacterial materials. So the weaknesses is phosphate glass has poor chemical stability, hygroscopic and volatile. The strength for the zinc oxide can enhance the bioglass chemical durability. The weaknesses of the zinc oxide is due to the fast recombination in photo-generated electron hole pairs. For strontium oxide, its strength, it has reaching a productive role in bone degeneration, and the weaknesses is the fragile nature of the glass. So we proceed with the impact toward the environment and sustainable development goals. The waste glass can be recycled, and the extreme sensitivity of the remelting process to any contamination. So the market analysis include the potential competitors from the shift from bioinert to bioactive materials. So the proposed solution use the matte quenching method to prepare the glass system. We can see we prepare the glass by using the mole percentage of sample and the mass of the sample. Next is the physical characterization to find the density, molar volume, and ionic packing density of the glass by using the density meter of Mittler-Toledo. So the structural characterization are used to analyze the presence of the crystalline of the glass system and amorphosity by using SRD, and to characterize the bond length of the glass system by using FTIR. Next is the thermal characterization to analyze identical thermal cycle using the DTA to trace the glass transition temperature, the start of crystallization peak, and the endotherm endpoint liquidus temperature. Next is the electrical characterization we use to analyze the glass system at high frequency and at low frequency. So the approach and overall concept we can see from the pictures in this slide, the sample 1 and until up to sample 5, the concentration of blue color increasing due to the increasing in copper oxide content. The characteristic of the glass system can be seen transparent, brittle, and thick. The glass is clear without any white spot. So the potential impact can be seen as an investment in infrastructure to collect, process, and distribute colored to manufacturers, and the effect of sustainable development goals. When a glass bottle reaches the end of its useful life, it is 100% recyclable, and glass have high resistance to corrosion and deterioration, reasonable strength, weight, and stiffness properties. So significant and uniqueness of the innovative product is the copper 2+ ion give the translucent blue to green color. The raw material used is chemical-free inert materials. Strontium oxide can strengthen the glass forming ability. Lithium phosphate glass has low melting point, low glass transition temperature, and high electrical conductivity. And the chemical durability of the phosphate glass is greatly improved by addition of zinc oxide. Next is the sustainability of the product. The phosphate-based glass able to release biologically active ions when degraded, and it's very soluble. Copper oxide, it shows the reduce of hygroscopicity and provide color centers. Lithium oxide can use in solid electrolyte in lithium cell. Zinc oxide can enhance bioglass chemical durability and photoluminescence. Strontium oxide can be used in bone regeneration and material hardness. So this is the triple button line framework for product life cycle and laser glass materials and components used for laser fusion. So for the market analysis, from the according graph China glass manufacturing market in the left side, there are a variety of glass which include the container, flat and fiberglass can be manufactured. So from the right side, we can see the graph global glass manufacturing market. We can see the unique qualities of glass such as its non-reactive nature and recyclability. So for the results, from the physical characterization, we can get the graph density versus copper oxide molar concentration, which is show the pattern of the graph is decreasing, while in graph molar volume versus copper oxide molar concentration, it shows the like parabolic pattern which is increasing. For FTIR method, the result we can get the band assignment from the wave number analyzed in the graph of transmittance against wave number. For the X-ray diffractions, we can see from the graph intensity against theta over 2 theta, the X-ray diffraction spectra did not have any sharp peaks, and the glass sample are amorphous in nature. From the differential thermal analysis, the glass transition temperature was determined from the second endothermic peak, whereas the crystallization temperature was determined by the first exothermic peak of DTA curve. So this is for low electrical impedance spectroscopy for low frequency at about 0.05 until 1 megahertz. We get the graph of log conductivity against log angular frequency, dielectric constant against frequency, and the graph of the dielectric loss against frequency by using the following equation. And it's same like at high frequency, which is from 5 until 30 megahertz. We get the same graph, but differently in the pattern of the graph. Okay, next is this is the publication from our supervisor, Dr. Nur Hafizah binti Hasim. Okay, that's all from us. Thank you.